Alright, in this video I'm going to answer questions on section 12.1. So this is section 12.1, homework solutions. I guess I'm not really going to answer questions. I'm going to work out just some of the problems, all right? Typically a homework assignment here is something along the lines of, 9 through 79 odd or something like that. So I'll work out a few problems. I'll start with problem 17. Problem 17 says, write down the first 5 terms of each sequence. And so in the lecture video, I taught you that is our symbol for a sequence. That just means the same thing that f of x meant back in Algebra 1. It's just saying plug in n. Instead of plug in x, where x can be any real number, it means plug in n, where n is 1, 2, 3, 4, 5, 6. And if that's not clear to you, you can go back and watch the video section 12.1 lecture, and I cover that in detail in that lecture. So, what do we know here? In problem 17, they tell us that our sequence has a general term of n divided by n plus 2. And again, this, it's not the same because this is a sequence, but if we were sitting in an algebra class, this would look like this. And none of us would have any kind of a panic attack about that. We would know what to do. We would know to plug in 0 and 1 and 2 and 3 and 8 and -6 and 4 sevenths and all the numbers we could think of. In fact, in chapter 4, we learned how to graph that function. We know that function has a vertical asymptote at -2 and it has a horizontal asymptote at 1. And if you don't remember those things, shame on you. But that's not what we're doing. We're not working with something this complicated. We overcame this problem in Algebra 1. Algebra 1, we were able to talk about domains and range. Algebra 2, we talked about the graph. Precalc, we talked about asymptotes. This is easier than this. What does this mean? This doesn't mean this, right? It doesn't mean this. It means our domain is 1, 2, 3, 4, 5. Our domain is the positive integers. So all we want to do is plug in the positive integers. So when it asks us for the first 5 terms, right, it wants us to find, notationally, it wants us to find this. Term 1, term 2, term 3, term 4, and term 5. The first 5 terms. Now remember, we don't write the inputs. Again, back in the lecture video I talked about, we don't write the inputs. This is outputs only. Outputs / range only. That's why it looks a little different to us. It's not different, it just looks a little different. So what do they want me to do here? They want me to plug in 1, plug in 2, plug in 3, plug in 4, plug in 5. And if you're asking, well, why didn't they tell me that? Okay, they did. That's what these brackets mean to us. We have to learn what that symbol means, okay? Our job is to understand the brackets mean sequences. Sequences mean our domain is 1, 2, 3, 4, 5, 6, etc. So the answer to problem 17, right, we're going to plug in 1. We get 1 divided by 3. 1 divided by 3. We plug in 2, we get 2 divided by 4. We plug in 3, we get 3 divided by 5. We plug in 4, we get 4 divided by 6. We plug in 5, we get 5 divided by 7. That's the answer. Now remember, this is the y values only. We're just making a t-table. Right? This is our t-table from back in Algebra 1, but it's our t-table with only the y values. That's all that is. Okay? It's nothing more than that. We don't write the x values because you and I know, hey, wait, 1, 2, 3. That's the third one in the list. So I plugged in x is 3. We don't put our domain in. We know that's the fifth one. So our domain element there was 5. Our domain element here is 4. Our domain element here is 2. Our domain element here is 1. We don't write them down as ordered pairs. Why waste the time of writing them down as ordered pairs when we all know they go in order? 1, 2, 3, 4, 5. Okay? So that's how you do problem 17. What about something like problem, 25? It doesn't get any worse. 25 says B sub n. Again, in my lecture video, we used A, B, C, S to stand for sequences. B sub n is equal to n, right? My general term here is n again, divided by e to the n. So what do they want me to do? They want me to write down the first 5 terms. So I'm going to plug in a 1, right? What am I going to get for an answer here? I'm going to plug in a 1, right? I start at 1. 1 divided by e to the first. Then I plug in 2. 2, n is 2, so 2 divided by e to the second. Now, n is going to be 3. 3, I'm doing the third term. So I get 3 divided by e cubed. Then I plug in 4. It's going to be 4 divided by e to the 4th. And finally, I plug in 5. That's going to be 5 divided by e to the 5th. Okay? And that's the answer. That's the answer to 25. Right? We're already a third of the way to the end. Now let's pick another one. It says, write down the nth term of the sequence. So we'll jump down here to number 33. All right. The ones where it wants us to write down the nth term. These are a little trickier. We have to use some imagination here, right? Our terms are 1, -2, 3, -4, 5, -6, and so on. So they want me to write down what's the function that gives me this. Well, remember, these are the outputs. These are the outputs. This is the range, right? That's the range. We already know what the inputs are. The inputs are 1, 2, 3, 4, 5, 6. So that gives us a pretty clear hint on what we're doing here, right? What are we doing? Well, it looks like our general term, right? Our general term is just n, doesn't it? But it's a little different than that. That's why I left some space. When I plugged in a 1, I got a 1. When I plugged in a 2, I got a 2. When I plugged in a 3, I got a 3. When I plugged in a 4, I got a 4. When I plugged in a 5, I got a 5. When I plugged in a 6, I got a 6. Okay, we've got that. But sometimes we got minuses. Sometimes we got pluses. Right? There's a plus here. We didn't write it, but there's 1 there. There's a plus there. There's a plus there. So what do? We put a -1 like this. And then we pick a power that works. We pick a power that works. So what do I mean by that? Well, if I put n here, does that work? We always start with n to see if that's going to work. What happens when I plug in a 1? Right here I get a 1. Okay, that looks good. What's -1, however, to the first? Because remember, this is my input. This is n. This is my input. What do I get when I put a 1 up here? Well, I get -1 to the first. -1 to the first is negative, but I want a positive. Let's try 2. Maybe it's going to get better. We'll plug in a 2, puts a 2 here. Now I've got -1 squared. -1 times -1 is +1. I wanted a negative sign. So I'm not getting what I was hoping for. We always start with n. Start with n, see if it works. If it doesn't work, it's not a big adjustment. Put a +1. Let's see what happens. Now plug in 1. Get a 1 right here. That's perfect. That's what I want. But I want a plus. I've got a -1. Now I have 1 plus 1, right? 1 plus 1. What's 1 plus 1? 1 plus 1 is 2. What's negative 1 squared? Positive 1. Positive 1. This looks pretty good. Let's plug in a 2 and see what happens. I'm going to put a 2 here. I'm going to put a 2 here. It's going to give me the 2. That's what I want. But I want a negative sign out in front. So I'll put a 2 up here because this is also n. N plus 1 is 3. What's negative 1 cubed? Negative 1 cubed is negative. So I'm going to get a negative sign in front of that 2. So now I got a plus, then I got a minus, and this is what's going to be my general term. How do we do these? Is there a formula for the general terms? No. You have to analyze and synthesize and put together the ideas to build those yourselves. All right, let's take a look at another problem. Let's do problem 39. Okay, we're just picking problems here. 39 says the first term of my sequence is 5, and the nth term of my sequence, right? This is not the general term. The nth term is 2 times the term that came before me. And it says a sequence is defined recursively. Write down the first 5 terms. We're going to write down the first 5 terms. So they want, we've got the first term already. So they want us to write down the first 5 terms. We're 20% of the way done. Now, how do we find the second term? Right? Well, using our formula, n is 2. So we would get 2, right? 2, because that's a constant. We get 2. And this would be a sub 2. N is 2 minus 1. Now, we can all do that math. That's 2 a sub 1. Well, a sub 1 is 5. So that's going to be 2 times 5, or 10. So to find a sub 2, I had to use a sub 1. So to go find a sub 3, n is 3. It's going to be 2. This is going to be a sub 3 minus 1. We can simplify that. That's 2 times a sub 2. 3 minus 1, 2. But we know a sub 2. That's 2 times 10. That's going to be 20. So our first term is 5. Our next term is 10. Our next term is 20. Now we got to find the first 5 terms. So what's a sub 4? Well, it's going to be 2, using our rule right here, times a sub 4 minus 1. That's going to be 2, and that's going to be a sub 3. We know a sub 3, so that's 2 times 20. That's going to be 40. Now it seems there's a pattern. 5 plus 5 is 10. 10 plus 10 is 20. 20 plus 20 is 40. It looks like our next term should be 80. So let's find out. What's our 5th term? It's going to be 2 times a sub 5 minus 1. That's 2 times a sub 4. That's going to be 2 times 40. And yep, just like we thought, it turns out to be 80. And they wanted us to find the first 5 terms. So we did. All right. Let's do another one. We'll do one like 45. 45 says, oh my goodness. It says my first term is a. It's not a number. It's just a. It's a constant. It's a. Okay, my first term is a. And then it says my next term is my previous term plus d. D is also just a constant. Okay, so we don't have numbers here. We don't have any numbers to work with. But it's not a big deal. We can do this. We can plug things into functions. Remember, sequences are functions. We're plugging things into functions. They look different. I get it. So what's my second term? My second term, using my formula right here, my second term is a a sub 2 minus 1, right? This is a 2, that's a 2 minus 1 plus d. Now, a sub 2 minus 1 is a sub 1 plus d. And they told me a sub 1 was capital A, so I get capital A plus d. So that's my second term. What's my third term? Well, my third term is going to be, using my formula right here, it's going to be a sub 3 minus 1, right? 3 plus d. That's going to be a sub 2 plus d. But we know what a sub 2 is. A sub 2 is already a plus d. Now don't forget that d. And we get a plus 2d. Again, it's all about patterns in chapter 12. We want to see patterns. We want to practice seeing patterns. How am I going to practice seeing a pattern? Well, my first term was a. My second term was a plus 1d. My next term was a plus 2d's. So I think I know what my next term is going to be. I don't think I'm going to be surprised if it turns out to be a plus. Yes, exactly. A plus 3d's. Well, let's see. My fourth term is going to be my third term, right? Because it's 4 minus 1. We'll go ahead and do the work. It's 4 minus 1 plus another d. That's a sub 3 plus a d. But we know what a sub 3 is. It's a plus 2d's plus another d. That's a plus 3d's. A plus 3d's. So we've got our first term, our second term, our third term, our fourth term. They asked us to find 5 of them. Using our formula, 5 minus 1, this is a sub 5 minus 1 plus d. But 5 minus 1, right, that's our formula, 5 minus 1. That's going to be a sub 4 plus d. Now we know what a sub 4 is. A sub 4 is a plus 3d's plus another d. That's going to be a plus 4d's. And we've got all 5 terms, so we can stop right there. Okay. So that's question number 45. Now, what about something like question number 51, right? 51. Let's take a look at this, because this is where we start practicing our sigma notation. So they give us here, they give us a sigma, Remember, that means to add. Sigma k equals 1 to n. So we don't have a stopping point like 6 where we're going to get an answer. We're just going to write it out all the way to n. And we have k squared over 2. So I'm not going to be able to calculate this because now if they would have told me to stop at 5, I could have written all of them down. 1, 2, 3, 4, and 5 is my inputs. And then I could have added those numbers up and got them an answer. But they asked me to go to n. So I start at 1. Remember how this works. I get 1 squared, right? 1 squared over 2 plus, I plug in 2 next. This is my index, my counter. I plug in 2, so I get 2 squared over 2. My next index is going to be 3, so I get 3 squared over 2. Then I go to 4 squared over 2. And I'm going to keep going, right, until I get to n squared over 2. This is where I start, right? Remember, this is where we start, and this is where we stop. And we add all of these. Now, what does this look like? Well, 1 squared is 1, so I get 1 over 2. 2 squared is 4, so I get 4 over 2. 3 squared is 9, so I get 9 over 2. Right? 4 squared is 16, so I get 16 over 2. And we just keep going until we get to n squared over 2. And so they asked us to write out the sum, so we did. Right now, we could factor a half out of all of these if we wanted to. You could have factored a half out of all of these and written it as, I don't know what the answer in the back looks like. You do. You looked. Maybe they wrote their answer like this. Right? You have the benefit of looking at the back and seeing what the answer is, and you're just going to match their answer. All right, so that's a question like one of the problems from 49 to 58. What's going on in 59 through 68? All right, so in 59 through 68, I'll do a problem like 61. I'll work out 61. Don't panic. I'm also going to do I'll try to do another one. So in 61, what do we have here? They have a half plus 2/3 plus 3/4 plus, and it goes all the way to 13. And they're even nice. They tell us this is 13 plus 1. So what do they want us to do here? They want you to write this out in sigma notation. That's what they want. They want you to tell them what's the general term. Where are you starting? Where are you stopping? Right? So here again, we're looking for patterns. You and I, we have to focus on what pattern is being utilized here. Now we're going to put an index in here. We'll start at 1. If we look at the numerators 1, 2, 3, all the way to 13. So maybe our numerator is just k. Now let's, if it is, right, k starts at 1. Now all I'm doing is looking at the top. Got to pull it all apart, look for the patterns. I'm looking at the top and I'm thinking, okay, all right, if I put in a 1, I get a 1. My next index would be 2, I get a 2, then a 3. If I do that all the way to 13, I'm going to get 1 on the top, 2 on the top, 3 on the top, 4 on the top, all the way to 13 on the top. So that's just k. Who's the bottom, right? Well, they kind of give us a hint right here, don't they? In this problem, k is 13, and the bottom is 13 plus 1. So maybe we try k plus 1 on the bottom. And then what do? We come up with a hypothesis. This blue problem is my hypothesis. I didn't write it in black because I'm still thinking about it. This is my hypothesis. I hypothesize that this is my solution, right? And then I check it to see if it works. And it does. So we'll go ahead and write it in black to show that it's our final answer. K is 1 to 13. K divided by k plus 1. These problems are fun. You just have to use your imagination, right? Let's try a problem like, we'll do something like 60. Well, what about 65, right? What do we got here? We got 3. Now that's just 3, right? And then we got 3 squared over 2. And then we have 3 cubed over 3. And then we go all the way to 3 to the n over n. Now, these were my favorite kind of problems when I was working with sequences and learning how to do these. Because when they don't stop at a specific number, this is the general term. The general term is right here. They have to write the general term down for us. What am I saying? I'm saying, well, when we go to look for the pattern here, right? When we go to look for the pattern, remember, we plugged in a 1 for that person. We plugged in a 2 for that person. Plugged in a 3 for that person. We plugged in an n for this person, right? So we're going to go k equals 1. We clearly stopped. We have 1 person, 2 persons, 3 persons. Over here we stopped at 13 persons, so we have 13 up there. Here we stop at n, so I'm going to put n terms, so I'm going to put an n there. Now, what does this look like? Well, we could get confused if we start here, right? Sometimes the first one has been simplified for us. So sometimes the first one has been simplified. Sometimes it's more confusing to start with the first one. Maybe we look right here. We're like, wait a minute. I have a 3 squared over 2, and I'm on my second term. I have a 3 cubed over 3, and I'm on my third term. So maybe I'm always going to get a 3 on the top, right? Everybody's got a 3 on the top. After all, this is 3 over 1. Wait a minute. Maybe that's my power. 2, 2, 3, 3, n, n. So maybe this is k right here. Who goes on the bottom? Well, on my first term, a 1 does. On my second term, a 2 does. On my third term, a 3 does. On my nth term, n does. So on my kth term, k does. And we're done. We're done. All right, I'll work out a couple more examples, and then we'll be finished with our homework solutions. Now remember, I'm not doing all the problems here. I'm just doing a few problems from each section so that you can take this, watch it as many times as you need to, read the examples in the book, and get your homework done, right? It's on you now. You've got to get the homework finished. Okay, there's one more section to the homework, right? One more section. And let's just take a couple of these problems out of here. I'll look at something like problem 69, problem 71, problem 73. I do problems exactly like those in the lecture video on 12.1. So if you need help on 69, 71, or 73, well, you shouldn't need help on those because you've already watched the lecture video on 12.1. So let's take a look at something like 75, right? That'll be the example I do from this section. So we have sigma here. K equals 1 to 16, right? 1 to 16. And what are we going to get here, right? They want us to find k squared plus 4. Now, how do we do this? We just start plugging in numbers, right? That's what we do. Now, we could break this up if we wanted to. We could use some of our properties, right? You could write this as k equals 1 to 16 of k squared plus k equals 1 to 16 of 4. Right? You have rules for summation signs. I showed you those rules in the lecture. Those rules are covered in your book. You need to read those rules. They make problems like this much simpler. We all know what this is. This is the sum of squares. We have a specific rule for that. We have a rule that says if you want to add k equals 1 to n of k squared, that turns out to be n times n plus 1 times 2 times n plus 1 all over 6. Now, that's a lot quicker than sitting here and going 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared on your calculator. You're never going to get this question done on a test. I'm going to assume, and your teachers are going to assume, you're going to use this formula and you're going to be done quickly. If you're sitting here banging away on your TI-30 or adding it up on a piece of scratch paper, you're never going to get done. So what do we know this answer is? Well, our n is 16. So this is 16 times 16 plus 1 times 2 times 16 plus 1 all over 6. What about this piece? Well, we have another rule that says if you have the sum k equals 1 to n of a constant, it's just n times the constant. Well, our constant is 4, and our n is 16. In other words, this piece right here is 4 times 16. This is how they expect us to solve this problem. They did not expect you to plug in a 1, plug in a 2, plug in a 3, plug in a 4, and add up 16 numbers. You'll never get done in time. So what does this equal, right? This is 16 times 17. That's 33, right? Times 33 all over 6. Well, 6 is 2 times 3. That's 11. That's 8. So we have here 88, 8 times 11, times 17, plus, over here we have 4 times 16. Well, that's 4 times 10 plus 6, because who wants to take 4 times 16? Nobody can do that. It's too hard. So that's 40 plus 24, right? Is that right? 40 plus 24. And so over here, you know, you can take your 88 times your 17. That's a 6. That's 5. That's, I can't do that. What is 56? 61. That's 88. 6, 9, 1496. So we have 1496 plus 24. So the 4 goes into there and makes that 1500. And then we have 60 over here now. So we have 1560. All right? Don't be doing 1, 2, 3, 4, 5, 6. Use your formulas. That's what problems 69 through 80 are expecting you to do. They want you to use the formulas. All right, that concludes my homework solutions. Remember, I'm not doing your homework for you. I'm helping you find ways to solve your homework problems. We're expecting you to be doing work. All right.